kids. It's the first time that we're going to be looking at a lesson online, and hopefully this goes well. But today we're going to focus on the idea of the distributive property. And we do have a couple goals that we want to focus on in class. We want to focus on these three goals. We want to be able to learn how to define what the distributive property is. We want to look at what terms are. We want to look at constants. We want to look at coefficients and what like terms are. Those are the terms that we're looking at today. And also, we're going to be able to, hopefully, by the end of this lesson, to be able to apply the distributive property to a specific set of problems, which I'll do, and then you guys will practice after I'm done. And then you guys will also be able to combine like terms, and you'll know what that means. But let's first look at the idea of what the distributive property is. And what the distributive property is for every real number that we're looking at, A, B, and C, the following is true. So if I look right here, this talks about the idea that we have A in front of a quantity B plus C. And what this is equal to is AB plus AC. So what we're doing is we're taking the A and we're multiplying it times the B, and we're taking the A and multiplying it by C. So if we look at a real life example right here with some numbers, let's just go over what the answer to this question is. I know based off the order of operations that I can add these two terms together and I get 20. Well, what we're doing is we're multiplying that term by 4, so the answer is 80. What the distributive property talks about is I can take the 4, multiply it by the 8, and I can multiply the 4 and multiply it by the 12. So I have 4 times 8 plus 4 times 12. Well, 4 times 8 is 32. 4 times 12 is 48. So if I add those two quantities together, I get 80. So the distributive property works the same way. Now this also works with subtraction, so I can take the A to the B, and I can take the A to the C. So I get AB minus AC. Now if I will look at this example, I know 9 minus 6 is 3 based off just the order of operations. And if I multiply 5 times 3, I get 15. Now if I apply the distributive property, I can take 5 times 9 minus 5 times 6. Well, that's 45 minus 30 is the same thing as 15. So let's look at some examples here. What we're going to try to do right now is just look at, are we able to apply the distributive property and try to put it in the simplest form. So let's just look at this first example. We have 3 times the quantity x plus 8. Now if I look at the distributive property says that I should take the 3 to the x and the 3 to the 8. So I'm going to do 3 times x plus 3 times 8. Well, 3 times x is just going to be 3x. And then 3 times 8 is 24. Now, it does not matter where the constant is and I'm multiplying times the quantity. It could be on the right side of the quantity as well, and the same thing works as well. So I'm taking the negative 7 to the 4 and the negative 7 to the 5b. So I'm taking negative 7 times 5b minus negative 7 times 4. Well, if I do negative 7 times 5, that's negative 35, which has a b afterwards. And I have a minus sign. If I take negative 7 times 4, I get negative 28. Remember, two negatives which were right next to each other makes a positive. So the answer is negative 35b plus 28. I have a couple other examples that we can look at. One in which we have a fraction, and we all know how we all love fractions, and we're going to take this fraction and multiply it by the quantity 16x minus 32. So I'm going to take the 1/8, multiply it by the 16x, take the 1/8 and multiply it by the 32. So I have 1/8 times 16x minus 1/8 times 32. Now remember, when I have a fraction times a quantity, all I really have to do with the 16x is put it over 1, and I multiply the top times the top, so I get 16x, 8 times the 1, and I get 8, minus, I'm going to put 32 over 1, I'm going to take 1 times 32, and I get 32, 8 times 1 gets me 8. So I have two numbers here, 16 and 8. How many times does 8 go into 16? It goes into it twice, so I have 2x. And then I look at 32 and 8. How many times does 8 go into 32? 4 times. So I get 2x minus 4. Now I could also do this in just regards to a negative in front of a quantity z plus 5. So what I'm doing with this is I'm taking the negative, multiplying it by the z. I'm taking the negative and multiplying it by the x. So I have a negative in front of a z, and then I have a negative in front of a 5. So I have a negative in front of a z. That's just going to make negative, oops, there we go. I have a negative z plus a negative 5. So I have a plus and I have a minus, which just makes it a minus 5. So what I want you to do, if you want to take a chance and just stop the video, I want you guys to try 5 through 8, which are the next 4 problems right after that. And when you are done, just start it back up. We will go over these problems in class tomorrow and just make sure you got the right answers. Okay, well, hopefully you guys had a chance to go through those 4 questions, but now what we want to look at is we want to look at the ideas of the next 4 terms that we were talking about earlier. We want to look at the idea of the term, what a term is. We want to look at what a constant is. We want to look at what coefficients are, and we want to look at what the like terms are. So what a term is it's a number, a variable, or the product of a number, or the product, we'll just get rid of that, or the product of a number and more than one variable. So what does that mean? We have different types of terms. So like 3 is a number, and that's just a specific term. We could just have a variable, which is just an x. That's a term as well. Or we could just look at a number followed by a variable, so we have 3x. These are all different types of terms. Or we can have a number followed by a term taken to a power. That's a specific type of term. Or we could have a number followed by a variable, followed by another variable, followed by another variable. These are all specific types of terms. Now, when it's just a number, it's called a constant. It's a term that has no variable. So like, for example, 3 is considered to be a constant term. These other examples contain something called a coefficient. It's a number that is in front of a variable. So when I look at x up here, it has nothing in front of it. I'll just write down x right here. If I look at x, there's nothing there, so really what it is it's 1x. 1 is the coefficient. When I look at 3x, the coefficient is really 3. And when I look at 4x squared, my coefficient is really 4. Now, what does it mean to be like terms? They are terms that end exactly the same way. So let's look at some examples of what like terms are and what like terms aren't. So let's look at this example right here. I have 2 terms here. I have 7a and negative 3a. Are these like terms? Remember, a like term is are terms that end exactly the same way. So if I look at these, this term ends as an a. This term ends in an a. So that means they are like terms. So I'm going to put a check mark there saying that they are like terms because they both end exactly the same way. Now let's look at this example, 4x squared and 12x squared. Well, it ends as x squared and x squared. They both end exactly the same way, therefore they are like terms. Now let's look at 6ab and negative 2a. 6 is followed by ab. Negative 2 is followed by an a. That's the last part. So when I look at like terms, I look at the ending after the number. Well, this ends as an ab, this ends as an a. So do they end exactly the same way? No, because in order for it to end exactly the same way, it either had to end as an a or an ab. So these are not like terms. Now let's look here. Now there's no number there, so we could say it's 1. Now, xy squared, x squared y. They don't end exactly the same way because they both don't have squares there, so they are unlike terms. So let's try to combine some like terms. Let's look at let's try to be able to combine like terms. So let's look at 8x squared plus 2x squared. They are like terms because they both end as x squareds. So all I do is write down the ending of that and combine the numbers in front of them. 8 plus 2 is 10, so my simplified form is 10x squared. Let's look at my next example here. I have 5x minus 3 minus 3x plus 6y minus 4. Remember, the idea of like terms is they end exactly the same way. So what I know right now is I have a number followed by an x, and I have another number followed by x. So these two are like terms. So if I look at 5x and 3x, I can put them next to each other. So I have 5x minus 3x. Now, I have just a constant term, and I have another constant term, so I can put those next to each other. So I have a minus 3 and I have a minus 4. And that just leaves me with plus 6y. Now, if I do 5x minus 3x, I know that's 2x. If I have minus 3 minus 4, that's going to be a minus 7. And then I just have 6y left over. So my answer would be 2x minus 7 plus 6y. Now let's look at this example right here. I have 7y cubed z minus 6yz cubed plus y cubed z. Well, I'm looking at the endings and I'm trying to find the endings that are the same. Well, it has a 7, y cubed z. It's not like yz cubed because they don't end exactly the same way, but it is exactly the same as y cubed z. So I can put them right next to each other. So I have 7y cubed z plus y cubed z. And if I add them together, I end up with 8y cubed z. And then I have a minus 6y z cubed. So now what I want you to try is I want you to try 12 through 14, and we will go over these problems in class tomorrow. So hopefully you guys have a good night and have fun. Thanks. Bye.